Welcome back, Physics 30. This is part 6 of the vector and scalar quantities section, and it pertains to pages 36 to 39 of the booklet. And the objectives for this lesson are to resolve a vector into the effective values of two independent component vectors. So we'll look at any vector and think of it as being able to be composed of two vectors. So what we're doing here is thinking about a resultant vector. It really is the result of two or more vectors. Okay, so as we saw from vector addition, we add various vectors and we get the resultant. So resolving a vector or a resolution of a vector means finding the component vectors. And what we will be doing is looking at two or more vectors that make up the resultant. And vector resolution is determining the components of a resultant vector. So what makes up a resultant vector? Kind of looking at it backwards. And the handy thing that we're going to do here is the two component vectors that make up an overall resultant are perpendicular ones. So if we can think of one vector being along the x-axis and the other one being along the y-axis, those are the two vectors that we're going to make up a resultant with. So using the x and y axis, thinking of those component vectors on the Cartesian plane, that will be the most handy, because then we'll be able to use some trig functions here, in particular sine theta and cos theta, in order to determine what their values are. Okay, so there are examples in the textbook, page 38 to 39. Looking at the horizontal component or the vertical component, I called them AX and AY respectively with the half arrow. And of course, remember what you learned back in pre-calc math, the Cartesian coordinate system here, quadrant 1, quadrant 2, quadrant 3, quadrant 4. If a vector lies in quadrant 1, it'll have a positive x and a positive y value. If the vector lies in quadrant 2, negative x, positive y. Quadrant 3, negative x, negative y, and then quad 4, positive x, negative y. And you likely, all students take calculus, one of those acronyms to remember which one of those is going to be positive and which one is negative. So if we look at the couple of examples here, vector v, it's 30.5 meters, north 55 west. So if we were to sketch out what that vector would look like, it would look something like this. So it's pointing north 55 west, so from straight north, 55 turning and pointing in this direction. So it's quadrant 2. Now I drew it this way, and if we look at the directions, it's a good way to show you which components we're going to be looking at. This vector here is going to be made up of a north vector and a west vector. So as you see here, north vector is going to be my Vy, or my y component vector, and west is going to be the x vector. Okay? And all we're going to do is just figure out the value of the x vector and the y vector. So if we look here, we can see that Vx, for example, is the opposite of the angle. And we know that hypotenuse here is the longest side, 30.5. So sine theta will be the function that will be helpful in using this one. So opposite over hypotenuse, or Vx over 30.5. Solving for Vx here, it's Vx divided by 30.5, so multiply by 30.5, multiply by 30.5, and Vx equals 25.0 meters. Now I put west here. You could also think of it as, since it's in this direction, any x vector in quadrant 2 is going to be negative. So 25 meters west, or negative 25. Looking to solve Vy, it is the adjacent side, so that involves the cosine function. So cos theta equals adjacent over hypotenuse, Vy over 30.5, and again multiply each side by 30.5, and we get Vy is 17.5 meters north. Or, once again, since it's a quadrant 2 vector, we know that our y value is going to be positive. So positive 17.5. Okay? Let's look at the next one. 245 kilometers south, 25 east. I'll get you to try it. First of all, sketch it out, and then see if you can figure out, well, in this case, I guess the tx and the ty component vectors. So you can pause the video now and do that. Okay, if you had a chance to sketch that, it looks something like this. So it's pointing in the southeast direction. So that means it's going to be in this quadrant, quadrant 4. And it'll have a positive x and a negative y value. So sketching this out here, we get ty. It's south, then east. So south, then east. And it's angling at a 25-degree angle. So I chose to figure out tx here first. Again, that's opposite over hypotenuse. And if you worked it out, you should get 103.5 kilometers. And this is pointing to the right, which is east, or plus 103.5. Okay? And now for figuring out what ty is, that is the adjacent side over hypotenuse. You should have got 222.0 kilometers, and it's pointing south. But of course that's equivalent to negative. It's pointing downwards. Our y vector is negative in quadrant 4. If you have this thing written down here, it'll save you tons of time. Okay, and the last one here, I'll get you to pause the video again, sketch it out, and then figure out qx and qy. Okay, if you had time to sketch that, it's west-south, west-south. So you can see it's going to be a quadrant 3 vector. It'll have a negative x and a negative y value. So if we figure out qx and qy, qx, of course, is the adjacent side. And the hypotenuse we know is 40.0. When you figure that out, you should get 33.9 meters west. Or, of course, that's the same thing as negative 33.9. Then figuring out qy, it's the opposite side over the hypotenuse. So that's using the sine function. And it should work out to be 21.2 meters, as you see, pointing south, which is equivalent to negative 21.2. Okay? So using the sine and cosine function to figure out what vertical and horizontal components make up these given vectors. Okay, so lastly here, one term, vector resolution, determining the components of a vector, and in particular the horizontal and the vertical components of a given vector. So we can say here, if we have a vector r, we can think of it as being made up of a horizontal and vertical component. And when we do this, when we figure out those components, that is termed resolved, quote unquote. So R has been resolved into components Rx and Ry, representing the horizontal and the vertical component. Okay, that's it for that lesson. We'll see you next time.